So 2.1 starts going over functions. With these functions, they give you a lot of examples on what functions look like, word value, like word parts of functions, all of that. In this slide, you have examples of different functions. So like the first one to the left, we have the height based off the years. So as your height gets taller, your age gets older. Okay, your temperature, the middle one, the temperature, and your date. Obviously, when the date goes by, your temperature changes. So the temperature is based off of the date. Your example on the right just deals with your postage, and it's the price per package. Obviously, your price per package deals with the weight. So the higher the weight is, the more the price is. Okay, so again, it's just different examples of functions. Some other examples of functions are the area of a circle is a function of its radius. So depending on its radius, your area either gets bigger or smaller. For the second example here, it tells you the bacteria in a culture is a function of time. So the longer something sits, the more bacteria grows. Next, you have the weight of an astronaut is a function of her elevation. So the higher the astronaut goes, the weight just is changing. And then you have the price of something for the demand. Obviously, the more the demand goes up, the price will change. This just goes into a little bit more about your area of a circle. If your radius gets bigger, your area is going to get bigger. If your radius gets smaller, your area gets smaller. So again, the way that we're looking at these is you have dependence and independence. In this specific example with this circle, your radius is what changes your area. So your area depends on your radius. So your radius would be your independent, your dependent would be the area. With any of these, your input is always your independent. Your output, what you're getting for plugging something in for X, is going to be your output or your dependent. Your function is just a rule that assigns each element in a set to exactly one element. So your X values cannot repeat with these functions. Okay. Your range of these functions are your X values. Your range of these functions are your Y values. Your domain is your X values. So anything that you're plugging in for X, or anytime you have an X value for these functions, those are your domains. Your range is your Y values, or what you're getting out of these functions. Independent, dependent, we went through that. This function machine, I'm not going to be bothering with this, but it just tells you, it gives you a visual of whatever you put into the expression for that function is going to give you an output, and that gives you your ordered pair that's on a coordinate plane. What we want to focus on with this lesson to start with is these function formulas. You're going to be evaluating for different terms that you're plugging in for X. So if you look at this first example, we have f of x is equal to x squared plus 4. This just means the function of x is x squared plus 4. So that input squared, and then you're adding 4 to it. The word form of this is just your input. What's happening to your input? You're squaring it, and then you're adding 4. That's it. Okay. For B, it tells you to evaluate f of 3, f of negative 2, and f of the square root of 5. We're going to plug each of these values in for x, in f of x is equal to x squared plus 4. When we choose the value that we're going to do first, like f of 3, we'll plug the 3 in for x. We need to rewrite that as f of 3 is equal to. The reason why we do that is because that's what tells us what we're plugging in for x when we solve it. So if we do f of 3 is equal to x squared plus 4, this is going to be f of 3 is 3 squared plus 4. Do you see how I keep the 3 in the parentheses? And that's done so that do whatever sign is attached to that term or that number, it stays in the parentheses. It's being squared, so the entire term gets squared. If it was a negative, like that f of negative 2, we want to make sure that negative's inside the parentheses with the 2, so that we were squaring that negative as well. So that we just simplify this. That 3 squared is 9. So this f of 3 is equal to 9 plus 4. And 9 plus 4 is 13. So f of 3 is equal to 13. So the reason why we keep this 3 in parentheses here is to let us know that we plugged in the 3 for x, and we simplified this expression, this x squared plus 4, and we got 13. This gives us the ordered pair 3, 13. Our next one we do is f of negative 2. So we're going to plug in this negative 2 for x and x squared plus 4. So this is going to give us f of negative 2 is equal to negative 2 squared plus 4. That negative 2 gets squared, so negative 2 times negative 2 is a positive 4. So f of negative 2 is equal to 4 plus 4. We add those, and we get that f of 2 is 8. For that f of the square root of 5, we're going to plug that square root of 5 in for x. So we're going to have f of the square root of 5 is equal to x squared plus 4. So f of the square root of 5 is equal to the square root of 5 squared plus 4. Remember, when you have the radical that has the same index as the power, they cancel each other out. So this square root and this square cancel each other out, and we're just left with f of the square root of 5 is equal to 5 plus 4, which gives us f of the square root of 5 is equal to 9. This just tells you again that whatever's inside that parentheses that comes after the f is what you're plugging in for x. So if we look at this example, we have f of x is equal to 3x squared plus x minus 5, and we're evaluating for f of negative 2, f of 0, f of 4, and f of 1/2. I'm going to start with that negative 2. So f of negative 2 is equal to 3 times negative 2 squared plus negative 2 minus 5. If we simplify that negative 2 squared, that's 3 times 4 minus 2 minus 5. I just simplified the addition and the subtraction next to each other as well. That's in front of that 2. From here, we're going to have 12 minus 2 minus 5. So f of negative 2 is equal to 12 minus 2 is 10. 10 minus 5 is 5. For b, we're finding f of 0. So this is going to be 3 times 0 squared plus 0 minus 5. The 0 squared is 0. So that's f of 0 is equal to 3 times 0. That plus 0 we don't need, so we can cancel it out. The 3 times 0 is 0 minus 5 gives us f of 0 is equal to negative 5. The next one we're going to find is f of 4. Oops. So this is going to give us 3 times 4 squared plus 4 minus 5. That 4 squared is 16, so that's f of 4 is equal to 3 times 16 plus 4 minus 5. From here, the 3 times 16 is 48, so f of 4 is equal to 48 plus 4 minus 5. The 48 plus 4 gives us 52, and 52 minus 5 is 47. So f of 4 is equal to 47. For D, we have f of 1/2. So this is going to leave us with 3 times 1/2 squared plus 1/2 minus 5. The 1/2 squared is 1/4, so f of 1/2 is equal to 3 times 1/4 plus 1/2 minus 5. To simplify this, the 3 times 1/4 is 3/4, so f of 1/2 is equal to 3/4. Now I'm going to turn that 1/2 and that -5 into something over 4. So that 1/2 is going to turn into 2 over 4, and that -5 turns into -20 over 4. Now that I have like denominators, I can just add and subtract my numerators, keeping my denominator. So that 3 plus 2 gives me 5. 5 minus 20 is -15. So this f of 1/2 is going to be -15 over 4.